After discussing the effect of catalyst in the rate of reaction, we realized that catalysts usually affect the rate of reaction by lowering the activation energy. Therefore, it means when there is a catalyst, then the time taken for that reaction to get to completion will be shorter compared to a case where there is no catalyst. Today, I want us to talk about the effect of light in the rate of reaction. Just like heat is a form of energy and can change the rate of a chemical reaction, we want to consider the following cases to confirm that light also has an effect in the rate of reaction. Case 1, plants only manufacture their food in the presence of sunlight. Meaning, photosynthesis only takes place when there is light. Another case, when hydrogen and chlorine are mixed in darkness, no observable change is seen. But when the mixture is exposed to light, we are able to observe an explosive reaction. So that is, hydrogen only react with chlorine in the presence of sunlight. Light changes the reaction rates of several chemical reactions, and this concept is applied in photography, photocopying, and so on. We have talked about photosynthesis. That is a process that green plants use to manufacture their food. Here, carbon dioxide and water combines in the presence of sunlight to produce glucose and oxygen. That is, during photosynthesis, carbon dioxide gaseous combines with the water in the presence of sunlight, that is light, to give us glucose, that is food, 12O6, and some oxygen gas also liberated from that process. So that is our case. To balance the equation, we have 6 moles of carbon dioxide gas and 6 water molecules. When light strike the film in a camera, silver bromide present on the film is broken down to silver and bromine. The amount of silver bromide broken down depends on the amount of light that reaches the film. I want you to get that. We are saying that it is the sunlight that is able, that is in a film, is the sunlight that is able to break down the silver bromide in the film into silver and bromine gas. And the bromine gas at room temperature we refer to it as a bromine liquid. So that is silver. To balance the equation, we'll have 2 there. The other is solid in state. Now, we have said that the amount of silver bromide broken down depends on the amount of light that reaches the film. The undecomposed silver bromide is converted into a soluble substance and washed away, leaving negative image on the film of silver. This image is then developed into the photograph. I want you to understand this. We are saying that the undecomposed, it is not clear that all the light will decompose the silver bromide. It is all the silver bromide are failing to decompose. So the undecomposed is what is converted to a soluble substance and washed away, leaving a negative image. This is something that you've had severally. A negative film of silver. This image is developed into the photograph. Now, from that given scenario, we realize that light is a factor that affects reaction. Even in a substitution reaction of alkanes, and we discussed this in the Form 3 chemistry, that is Organic Chemistry 1, where we said that methane is able to react with the chlorine gas to form chloromethane just in the presence of what we call UV light. Meaning, it is because of this light that the reaction is able to take place to give us the chloromethane. That is plus hydrogen chloride. This hydrogen in the methane is substituted by a chlorine atom to form chloromethane, and the remaining chlorine atom are then combined with the substituted hydrogen to form hydrogen chloride. So from this reaction, it is this sunlight that is able to make the reaction possible. Meaning, in the absence of sunlight, then chlorine does not react with the alkane. Bromine will not react with the alkane. And I think if you can remember, when you are talking about the substitution reaction between alkanes and the halogens, it is this sunlight that will make the alkane to decolorize bromine water. Without that, there is nothing that will happen. No observable change will be realized because there will be no reaction taking place between the halogen in question and the alkane. When solutions of silver nitrate and potassium bromide are mixed, then a pale yellow precipitate, which is silver bromide, is formed. If you try to get back to the photograph story, the presence of sunlight will make the pale yellow silver bromide to decompose to a gray silver metal and reddish brown bromine liquid. And we have said that such breakdown will only take place when there is presence of light. So that is all about the effect of light in a reaction rate. That out of that, we are able to conclude that light increases the rate of reaction by looking at several scenarios where without light, reaction does not happen, and with the light, reaction is able to take place.